Hello friends, let us start the part 2 of the lateral earth pressure. Before that, I will advise you to watch the part 1 as well as shear stress to understand this video in a better way. So, till now we have learned that sigma V is the vertical pressure acting on the soil element, and because of this vertical pressure, a lateral pressure has been developed in the soil, which is K times vertical pressure sigma V. Now, this K will depend on the movement of the wall. So, we have three types of wall movement. One is the wall at rest, the wall is not moving. Another is the wall is moving away from the backfill, and one is the wall moving towards the backfill. The wall moving away from the backfill is known as active state, and the wall moving towards the backfill is known as passive state. So, we have three stages. One is at rest, active, and passive. Now, the coefficient of lateral earth pressure at rest is 1 minus sin phi. For active, it is 1 minus sin phi over 1 plus sin phi. And for passive, it is 1 plus sin phi over 1 minus sin phi. No failure plane. The failure plane is at angle 45 plus phi by 2. The failure plane is at angle 45 minus phi by 2 with the horizontal. I have explained what is plastic equilibrium in the previous video. Sigma h is K times sigma V. Okay. Now in this also, sigma h is K times K naught Ka sigma V, and sigma h is Kp sigma V. Is it okay? Now, in this case, sigma h will be less than sigma V, and in this case, sigma h is greater than sigma V. This is very important to understand, and in this case also, sigma h is less than sigma V. This we have learned in the previous video. Also, the most important part is sigma h is equal to Ka sigma V minus 2c root of Ka, and in this sigma h is equal to Kp sigma V plus 2c root of Kp, and I have explained Ka and Kp. Let us take the active earth pressure for cohesive soil. So, for any depth z, the formula will be gamma z Ka minus 2c root of Ka. I make you again remember that Ka is 1 minus sin phi over 1 plus sin phi. Please remember this. Okay. So, if we see the cohesive soil, then at z equal to 0, what we find that the sigma h is minus 2c root of Ka, which is very important. It shows that at the top of the cohesive soil, the earth pressure horizontally is negative, which means that the soil is in tension, which I have shown here. Okay, so as the depth increases, this tension stress is reduced because of this gamma z, and at a point which I call it z0, this sigma h will become 0. So sigma h will be 0 at z equal to z0. So what will be z0? So put this in this equation. So what you get? 0 equal to gamma z0 Ka minus 2c root of Ka. Solving this for z0, we get 2c over root Ka. Okay, so this is my depth from the top where the lateral earth pressure will be 0. Is it okay? And above this, the lateral earth pressure will be negative, which means tension, and below which the lateral earth pressure will be compressive. Now, if we come z0 down, okay, then what we find that this negative and this positive will cancel each other, and the net pressure is 0. Okay, so net pressure is 0 at 2z0. So what is my 2z0? 2z0 is the critical depth below which there will be net pressure is 0. Twice z0 up to which the wall will not face any pressure. Okay, so literally if I can say, I don't require a wall because the pressure given by the soil up to this point is 0. So the pressure is 0. So I don't require a wall up to twice z0. And this twice z0 is known as critical depth, which is important. Many a times it has been asked in the interview and in the exams also, that this twice z0 is the critical depth, and this is important because I don't require a wall technically or practically, which is 4c over gamma Ka. Is it okay? So this is the concept of the critical depth, which is useful for only cohesive soil. It is not applicable for non-cohesive soil because C is 0 for non-cohesive soil. Okay. Now if you simplify it further, if I have a pure cohesive soil like here, you will see that the phi is 0 for pure cohesive soil and Ka is 1. Hence, critical depth is 4c by gamma. Okay, friend. Please remember this. It has been asked in lot of times in many ways. So please remember this formula or this formula. This is a generalized formula and this is a special formula for pure cohesive soil. Now we come to the Rankine theory. Rankine, what we have studied till now is a part of Rankine theory, but he has made some assumption which you should understand. First assumption and the basic of any soil mechanic part is that soil is homogeneous, isotropic, and he has studied on cohesionless soil, but later it is found that the theory is applicable for cohesive soil also. So that is the very first assumption of the Rankine. Second assumption was that the soil is under plastic equilibrium. I have discussed in the previous video. Watch my previous video to understand what is plastic equilibrium. Third and the most important assumption, what he said, that the wall is smooth and no friction between soil and wall. This is very important, friend. What he said, that if I have a wall and a soil, then at the interface point, at this place, there will be no friction, which is not possible. But this holds good for active soil, since the wall is moving away from the soil, so the friction will reduce and the theory is well applicable for active state. But this cannot be possible for passive state because the wall is moving towards the soil and friction will increase to a greater extent. So the Rankine theory is more applicable for active state and less applicable for passive state. Now I will take few of the conditions which are applicable in the field on different type of soil and different loading condition. Okay, so but please remember that our formula is same. Okay, So what is my formula? My formula is sigma horizontal active is sigma V Ka minus 2c root of Ka, and sigma horizontal passive is sigma V Kp plus twice c of root Kp. Now, if there is a surcharge, okay, like a road or some bridge or something on the road, on the soil, then what will happen? There is a surcharge of Q. Then my sigma V at this point at z equal to 0 will be Q, and at any depth z it will be sigma V will be Q plus gamma Z. Okay, so if you put sigma V here in this portion and in this portion this value, then what you will get is written here. So sigma A will becomes gamma Z Ka minus 2c root of Ka plus Kaq. Okay, Kaq is because of this Q, which is a surcharge. Similarly, for passive state, if you see, it will be gamma Z Kp plus 2c. So sigma passive is equal to sigma V Kp. So sigma V is now what? It is Q plus gamma Z. So if you see here, so Q into Kp plus gamma Z Kp plus twice c root of Kp. Is it okay? So I have a constant increase of sigma p, which is Kp into Q. Now come to the second part, when the soil is saturated. Friends, this is very important. When the soil becomes saturated, what will happen? So when soils become saturated, we will have our sigma V as gamma submerge into Z. Okay, for the soil. So at any depth Z, my sigma V will be gamma submerged into Z. Okay, so whenever whatever it is, when you put, what will happen, that sigma horizontal will be gamma submerged into Z in place of gamma Z. But the important part is this gamma W into Z, which is the pressure of the water, because we have not included the pressure of the water laterally. So the K for water is 1, so it will be gamma W into Z. This is very important. Clear? So let us take for active state, what will happen? For active state, it will be gamma submerge into Z into Ka minus 2c root of Ka, okay, plus gamma W into Z. Similarly, for sigma P, it will be gamma submerged into Z into Kp plus 2c root of Kp plus gamma W into Z. Is it okay? Which I have shown in the graph in this way. So what happen? Due to this factor, I will be having this graph, and for this I will be having this. Similarly, for the passive also, this can be drawn in this way and this can be drawn in this way. So you have to use two pressure diagrams. Both will act at the same depth, Z by 3, Z by 3, with the total pressure will be half gamma W Z square, and in this it will be gamma submerged Z square into passive state. Is it okay? So do remember to add this gamma W into Z. Many times the student forget this gamma W into Z. This is very important. Now the third case is when we have two soil layers. So it is very simple to understand this. When you are dealing with first soil layer, do it as we have done in the just right now. But when you come to the soil 2, you will take this load, which will be gamma 1 into Z1 as a surcharge. Is it okay? So all the theories which we have applied for the surcharge will be applied for the soil too, at a depth of any depth z, starting from z1 to z2. Is it okay? So you will convert this soil into a surcharge of gamma z1, and I have just now in the previous part I have explained you how to handle this surcharge load. Okay, so your total numerical or total problem will shift to this part only by using q is equal to gamma 1 into z1. Okay, so this is very simple. Just whenever the layer changes, which means the density changes, okay, then we will convert this to this part. I will explain you in the numerical part and do 1 or 2 questions how to take this, so that will be more clear to you. Now the third part is, till now we have taken that the soil layer is horizontal, but we can place the soil at an angle beta which will be less than phi. Is it okay? At an inclined surface. Then the coefficient will change, and the new formula that will become is Ka is equal to cos beta into cos beta minus cos square beta minus cos square phi over cos beta plus cos square beta minus cos square phi. I advise you to remember, we have derivations also, but at the competitive level we don't require derivation, but we require this formula. Now the it looks like a very typical formula, but it is very easy to remember. Just remember that if you put beta equal to 0, you should get our initial formula. So if I put beta equal to 0, then in this formula what will happen? Cos beta is 1. So 1 multiply by again cos beta, which is 1, because beta is 0. Beta is 0. Beta is 0. Beta is 0. Is it okay? So if you see, then what will be my formula? 1 minus root of 1 minus cos square beta, cos square phi over 1 plus root of 1 minus cos square phi. Okay, so if I simplify, what I will get? 1 minus sin phi over 1 plus sin phi, which is my original formula. So it looks like cumbersome, but it is a very simple formula. And remember that beta cannot be more than phi, since the soil will not be stable. The important part here is, friends, that the pole in our mode circle will change. In the previous video also I have little bit discussed that for active state my pole is here. Okay, active. And for passive state my pole is here. Okay, but now since for beta diagram for active state, let us say this is possible for active state. Active state, since my angle is changed, so pole will shift here. This will be my pole. Is it okay? At an angle of beta. Okay, so the pole will change at an angle of beta. And the another important thing here is that my lateral pressure, the lateral horizontal pressure will not be OE, but it will be OB. Okay, so I have written here that OB is my lateral horizontal pressure. Okay, and OA will be vertical pressure, this part. Okay, it will not be OD. Please remember these two things. Is it okay? Clear? Which is not in the case when beta equal to 0, it will again fall to the same part. But if beta is having some angle beta, then it will move up. This is very important and has been asked in quite of the examination. Now the second thing is, if you see the diagram, then the total direction of the total pressure will also change. It will change to a beta angle. initially it was horizontal, which we have studied in the above part, this way, that this is horizontal. Okay, now it will shift to a beta angle since our angle has been changed. Okay, so just two changes. One is the formula for K A and Kp, and second is it will become same, value will be same, but the other component will be, I have cos beta, and the inclination of the total pressure will be at an angle of beta. So what will be my total pressure now? Half Ka gamma z beta square means the area of this triangle, to be more technically correct, area of this triangle, and the last ordinate will be at an angle of beta. Okay, so it will be Ka gamma z cos beta. Okay, similarly here the last at depth z, it will be Kp gamma z cos beta, and the total pressure will also change to an angle of beta. Is it okay? So please make a note on this. Now let us take the Coulomb earth theory, okay. Let us take the salient features of the Coulomb theory of earth pressure, since the exact theory and its main derivation and other parts are beyond the scope of this course. So what Coulomb has done, he has taken the friction between the wall and the soil, okay, and he has assumed a wall which is inclined at angle alpha. So he has taken a most generalized case where the wall is also inclined at angle alpha. Is it okay? Then what he has done in his theory, that he has taken lots of trial wedges. He has not said, as said by the Rankine, that the failure plane is at an angle of 45 plus 5 by 2 and 45 minus 5 by 2 as in active and passive state. He said that you take a trial wedges and find out what will be the angle at which the failure take place, and for every trial wedges he make the equilibrium triangle, which is not applicable in nature. So mind it that the Coulomb theory is not applicable in the nature, and the basic static equilibrium condition is not satisfied. That is the problem with the Coulomb's theory. Is it okay? So what other things he has said? So I just repeat, it is not applicable in nature. Okay, the part is that the static equilibrium condition which he draws by the triangle, I am not going into the detail of this. So basic equilibrium conditions are not satisfied. It's not satisfied. Is it okay? So many a times you will find that people are still stick to the Rankine theory. But what he said is important from objective point of view. So he said the wall is at an angle alpha. So the reaction given by the wall will be at an angle delta, which he call it angle of wall friction. So delta is angle of wall friction. Okay, and for most of the cases you can take this delta as 2/3 of phi. Is it okay? For concrete wall this is perfect. You can take the angle of wall friction as 2/3 of phi. Is it okay? Clear? The next part is the trial wedge. So he takes a lot of trial wedges and make this diagram. But the important part in this trial wedges, the failure plane is the value at which the highest value is obtained for active earth pressure. Please remember this thing. Okay. And for passive state, the value should be minimum for the failure as he described. Okay, just remember these things and don't go into the detail first part. Is it okay? Now the next is, if the wall is smooth, okay, then delta will be 0. So now the Coulomb and Rankine result matches when the wall is vertical, the inclination of the soil is 0 and soil is cohesionless. Then Coulomb and Rankine result will match. But in numerical, if you find friends, in the examination, lot of Rankine question has been asked and less weightage is given to the Coulomb theory. That's why I have also taken Coulomb theory in a shorter part and emphasis on the Rankine theory. Thank you friends for watching this video. I hope you learned a lot of things. If you like this video, give a thumbs up and please write a comment for any suggestion which you want to give me. Also, you can WhatsApp me for any query or any doubt which you are facing while watching the video. Thank you. Enjoy civil engineering.